Example 2. An open-top box is made from a 24-inch by 36-inch piece of cardboard by removing a square from each corner of the box and folding up the flaps on each side. What size square should be cut out of each corner to get a box with the maximum volume? Let's first go ahead and sketch what this means. Okay, we have an open-top box that's going to be made. And we are cutting, well, let's see, each side is 24 by 36. And we are removing a square from each corner. Now, these are all going to be the same size, so we're going to go ahead and say these are x by x. Okay. That's actually what we want to find. We want to know what the value of x is. Now, we want to maximize the volume, so let's go ahead and determine a function for volume. Now, if you can imagine, what we're doing is this. Here is the bottom of our box, and the dimensions of that box are 24 minus 2x, because we're taking x out from each side. So that is 24 minus x. The width here is 36 minus 2x. And the height of that box, once we fold those flaps up, that's going to be x. All right, well, multiplying that out, we get 864 minus 120x plus 4x squared, and we've still got the x term. So 864x minus 120x squared plus 4x cubed. All right, now, taking the derivative of that to maximize it, we get 12. I'm going to go ahead and rearrange this. 12x squared minus 240x plus 864. 64. Now, setting that equal to 0 to find our critical points, we factor a 12 out. X squared minus 20x plus 72 equals 0. Now, it'd be great if that factors, okay, to make that equal to 0. It does not, actually. I've already tried that. So let's go ahead and use the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. So that would just be 2. This simplifies to 20 plus or minus, and let's see, that's 400. 288. So 400 minus 288. Let's go ahead and figure that again. 400 minus, that's 112. And let's see, 16 I believe goes into that. Yes, okay, so this is 4 square root of 7 over 2, which means, okay, this is equal to 10 plus or minus 2 square root of 7. So our critical points are at those two values. So let's go ahead and do a sign diagram. We have 10 plus 2 square root of 7 and 10 minus 2 square root of 7. Now, these are each approximately 4.7 and 15.3. So they are both in our domain. Our x value has to be less than 24, but greater than 0. They're both in our domain. So testing some points here, these are both 0. Our derivative is 0 at those points. It's increasing to the left, decreasing in between, and increasing. So it appears that we have a maximum at 4.7, or 10 minus 2 square root of 7. So we have a maximum volume of something at x equals 10 minus 2 square root of 7. Now, evaluating that, we get 1825.3 feet cubed. So there's our maximum volume. And if the side we cut out is 10 minus 2 square root of 7, that would be it. So actually this question is asking for the value of x there, so 10 minus 2 square root of 7. Want to know what size square to cut out. But our maximum volume would be 1,825.3 feet cubed, approximately.